Okay, I think we will make a start. Hello everyone, and welcome to the Department of Materials Open Day Current Student Q&A live stream. Thank you for joining us, and please ask away with your questions. So if you're watching this on YouTube, if you're on our YouTube channel, there's a link in the description below the video where you can click through to the Open Day website. And if you scroll down to the bottom of that page, you should find the video from the live stream and a Slido box where you can type in your questions. So that's where you want to be putting in your questions. And the plan is we will read them on the Slido, and then I will ask them to our lovely student ambassadors who are here today. So student ambassadors, would you like to turn on your cameras and your microphones and introduce yourselves to our audience?
I'll go first then. Hi, I'm Bradley, or Brad. I am a PhD student, first year PhD student here at the Materials Department at Oxford, and I also did my 4-year undergrad here as well before starting my PhD.
Hi, I'm Charlotte, and I'm just finished my 3rd year doing material science as an undergrad still. I'm at Mansfield College.
My name is Cara. I'm a 4th year undergrad, just finished the course. I'm at Mansfield College as well.
And hi everyone, my name's Anthony. Like Cara, I've just finished my 4th year too. I'm at St. Catherine's College as well.
Okay, brilliant. So let's get stuck into some questions. So, right, so there's a good one to start off with here. What made you choose material science over things like engineering and physics? So why did you choose materials? Who wants to kick us off with that one? Charlotte, go ahead.
I was really stuck between wanting to do like physics and chemistry, maybe like natural sciences, physical chemistry, something like that. But I also wanted the engineering aspect like partly involved, but I couldn't really decide really. So like material science felt like the perfect kind of intersection of still getting to do a bit of everything and still being like doing everything to a pretty high standard, but without having to get rid of one of those elements.
Anyone else want to jump in? Cara?
I was originally interested in biomaterials actually, and I did like a Head Start course in biomaterials, and after I did that, I realized I wasn't interested in the sort of biology bit of it. I was interested in the sort of materials and the prosthetics, and that's what kind of led me on to material science and sort of how things are made. And the engineering aspects of that at a small scale really interested me.
Brilliant. Brad, how about you?
Yeah, like Charlotte, I was looking at physics, engineering, something along those lines before I realised that material science was a subject. And then kind of once I'd realised that material science was a subject, I realised that that was kind of the exact overlap between physics and engineering that I really wanted to do. And from that point, it was a bit of a no-brainer for me. And I quite like the practical aspect of it. I would say, especially out of the courses at Oxford, it's one of the more practical ones. Even things like engineering here are quite, it's called engineering science, the course, rather than engineering. So they're all quite theoretical, whereas materials I quite like, especially doing research now, I quite enjoy the hands-on aspects of it and things like that.
Brilliant. Does anyone have anything else to add? Otherwise, we'll move on to the next question. Okay, so that lends itself quite nicely onto another question, asking how much lab work does the course involve? And in 1 week, how many hours would you spend in the lab? So who wants to start?
I'm happy to start on this one. So I believe in 1st year, so we had 2 lab sessions every 2 weeks. So it'll be 2 in 1 week and then a 1 week off. And those lab sessions were about 3 hours long. So it would be 6 hours every 2 weeks. Whereas in 2nd year, it was slightly more. And I believe it was 9 hours every 2 weeks. which so 3 hours for three days, Monday, Tuesday, Wednesday, for my particular experience when I was in second year, which might sound like a lot, but I could definitely say it is very doable. And sometimes in second year, you do things well enough over the 6 hours, the first 6 hours, that you don't need to spend the final day in to finish up your experiment. So again, it might sound a bit like, oh gosh, that's 3 afternoons in a week, but it's definitely very doable. And you work in groups and you have supervision alongside it. So you have a junior demonstrator, you have the senior demonstrator who's there to sort of guide you along the way. So yeah, so slightly more in second year in comparison to first year, but overall still quite manageable.
Nice. Cara, do you want to add something to that?
Yeah, I just wanted to say that so the course has slightly changed. So I think people applying now will have less practical work than Anthony and I would have done, and also Brad. So I think it's yeah, it's still a good amount of lab work. You'll get familiar with the lab, and honestly, the more lab work you do, the better, in my opinion, because I feel like I'm quite prepared for like a research. Well, when in my final year, when I did my research project, I felt quite prepared for research work. Yeah.
Nice.
Brad?
Yeah, just from what Anthony was saying, so the first and second year labs that you do, and like you said, those are the rough amounts of time that you'll be spending in them are quite, they're a little bit more in depth than school practicals, but in a way that you're kind of given a lab script and shown what to do, they're broadly similar. They're longer, but you're still kind of following an instruction set. By the time you get to third year, you can start choosing either computational practicals or more physical practicals to do, and those start to become individually led research projects. So you do at least one of those in third year, and you also have a team project in third year. And then by the time you get to fourth year, you're spending your whole time doing a research project, which could be in the lab, it could be computational. But they're much more, they're very, at the end of second year, it changes quite a lot in terms of what the way you're doing the practicals, rather than following a set of instructions. You're starting to design the practicals yourself.
Nice. And it's also worth mentioning that our teaching labs in the department are currently undergoing a really nice renovation this summer. So anyone joining from the next academic year onwards will have lovely new teaching lab equipment and facilities. So that's another thing to bear in mind there. Brilliant. Thank you for that. Next question. What was your favorite part of the course? Brad again, go ahead.
For me, it was definitely the fourth year. So we would do our final exams at the end of third year. So you finish all of your lectures, your tutorials, your teaching ends at the end of third year, and you spend the whole of your fourth year in a lab doing a research project. Last year, mine was cut short a little bit because as we were all sent home after in March. But it was still a lot of fun. You get stuck into a research group with some of the best professors and postdocs that will help you out with your research project, and a lot more freedom to kind of do what you want to do and things like that. It was a lot of fun. So yeah, that was fourth year was definitely my favorite part.
Nice one. Charlotte, how about you?
I know we've just talked about it for a while, but I really enjoyed doing all the practicals, just because material science is a relatively small course, and practicals you do in groups, and then you work with kind of the other groups, you kind of help each other along as well. So it means you really get to know everyone, like within a few weeks, really we all knew each other's names on the course. And yeah, it's like a really great time to like work together, make more friends. So yeah, even though the practicals can be a little bit hard, they were always, you felt like so supported, and they made really good friends from them too.
Yeah, that's really nice to hear. The working together and collaborating, it's always really nice in science. Brilliant. Cara?
Yeah, I just have to agree with Charlotte there, with the the practical work being a great part. My favourite was definitely the third year characterization course, which we're given sort of a range of materials, and then we go away and do the characterization we want to. And I was looking at archaeological cannibals samples, so it was really fun.
Oh, that sounds really cool. Brilliant. So next question. What does a normal day entail for yourselves? How much studying and work is there in a day? So I think you've all finished for the term at the moment, haven't you? Apart from Brad, obviously, because research never stops when you're a D4 student. But what was a typical day like back when it was term time? Charlotte?
So if I talk about like a typical first or second year day, as I'm sort of closest to that age out of the four of us, you normally have about 2 lectures in the morning, sometime between starting at 9 a.m. up to starting at 12 o'clock. Sometimes there are a couple of hours in between, which are really handy. Normally end up going to like the materials cafe or sometimes a library, but normally a cafe to like start doing some work on some of the problem sheets together. It's really nice between 1 and 2. There's never any teaching, never any classes or anything, so you always get time for lunch. And then in the afternoon, if it was one where we would be in labs, then we spend 3 hours in labs and they'd finish by 5. And if not, I might have an hour tutorial, so you and 1 or 2 friends with a tutor talking about one of your problem sheets, or it'd be a good time to start on the problem sheets that were due the next week or the next couple of days and maybe do a bit of the lab report writing. Normally found that you can work 9 to 5 and you don't have to work like massively long hours outside that. So there'd always be time in the evening to do sports or clubs or go to talks or just like hang out with friends.
Nice. Brad, go ahead.
Yeah, I'll just go on from that. So first and second year, like Charlotte said, are quite similar with and fairly routine. Third year, you start to change a little bit. Cara spoke about the third year characterization project earlier. So that you get, is it 2 or 3 weeks, 2.5 weeks, something like that, at the start of the term, and you don't have any lectures or anything like that for those few weeks, and you just focus on your projects. There's a team design project in third year as well, where you don't have any lectures for 2 or 3 weeks, and you just focus on that. And so you just do those rather than doing the labs in third year, where you just have the afternoons in a week or something. The lab work is condensed into these intense 2 or 3 week periods. And then the other periods for the rest of the term are no practicals, and you'll obviously be doing probably more work in those, more written work in those times. And then obviously you get towards the end of third year, and revision starts to become a pretty heavy part of your life for a few months leading up to exams. And then in the fourth year, it goes to very much a 9 to 5 day doing research. You're kind of forced into that a little bit. You can't really do a lot of the lab work you have to do while other people are in the building and things like that. So you kind of have to do you're forced into a bit more of a set normal routine.
No more all-nighters in the labs. Brilliant. That's really, really good to hear. So I've had a couple of questions asking about interviews. So what were your interviews like? What sort of questions were you asked at interview? Can you remember? Someone want to start off on that? Charlotte, go ahead.
So I got asked a couple of things about my personal statement, but not really so much about like, like when did you learn about teamwork? Not those kind of questions, much more like science questions, like tell me about like the nitty gritty of like these things that you've talked about in your personal statement. And then I got asked like a few maths questions, a few physics questions, kind of starting on things that you will have learned and then drawing in other things. Like I remember I was doing a question that kind of like about physics, and then suddenly it was like, oh, we're talking about entropy. Like now we've jumped into chemistry. So it's kind of things I like was familiar with, but not necessarily like in that context. They were about like 30 to 40 minutes, and we had them at 2 different colleges, which is like pretty typical. They're nothing too scary. They're often like maybe 2 or 3 tutors and just one of you, but they really try and make it like a collaborative thing. You're like writing down lots of things, drawing diagrams. It's kind of like a sort of trial tutorial, which is what you have like at Oxford. So they want to see like how you learn, how you think. You're willing to talk through what's going on in your brain, or do you just keep what's in your brain, or can you communicate it out? Yeah.
Nice. I think Cara, you had your hand up next.
So I agree with all Charlotte said. I had 2 interviews, and I was asked about points on my personal statement, talking through those, asked about the science behind it, and if they had any questions, just discuss it. I'd frame it more as like a discussion sort of period between you and the interviewees, and I was asked some maths questions, talked it through. Then sort of, I was in one of my interviews, I was given a bit of carbon composite, and asked to just talk about it, and that was the question. Yeah.
Cool. Brad, I think you were next.
Yeah, I think mine might have been slightly different to what these two described. I wasn't asked anything about my personal statement in mine. I was given, like Charlotte was saying, there are things, some science questions based on things that are kind of A-level syllabus style, but asked in a different way, like you said. And I got my questions were quite based around estimating things, kind of giving an answer to the correct order of magnitude kind of question. Based around some equations and things like that you would know from A-level science. And like Cara was saying, the question where you're just given a material or a bit of something, a bit of a car maybe, or something, you're just given it, not really told what it is at all, and just asked to talk about it, maybe try and work out what it is, what it's used for. That kind of thing is seems to be a bit of a favorite from a lot of the tutors. So that's often a good one to practice.
Nice, top tip there. Anthony, how about you?
Yeah, so I think the interview experience was definitely quite interesting for me, and especially because I wasn't well on the day when I had my interview, but thankfully I didn't want to show the tutors that, because I was a bit nervous that if they think I'm unwell, are they going to have a bad impression of me? But I managed to pull through. And I guess one of the things that I remember, so similar to what Charlotte and Cara said, they asked me about, so I managed to do an extended essay during my A-levels, but they asked me about what my extended essay was. So that was kind of like that was the first question I got asked. So it was a nice way to ease me in, because it was something that I was comfortable talking about. And then similar to what Brad said, my tutors then sort of put material in front of me and sort of asked me to describe the way in which it might have been processed, so how they thought it might have been made. And thankfully I'd done a summer school, which introduced me to a specific material science technique, which I guessed and managed to be the correct one. So I was quite happy with that working out. But another thing that I also distinctly remember being asked was a graph sketch in my second interview. And that was definitely something which I'd sort of had an opportunity to do quite a bit of practice of in preparation for the interview. So, and speaking to other friends, it seemed like it was a relatively common thing, at least at my time of interviews, to have been asked a graph sketch. So would definitely recommend practicing on that. And I know my one was a little bit weird, but sort of like walking through the process, I guess I was able to do it. And I guess if I could just summarize, we just always encourage you in an interview, just speaking out loud. Even if you feel like you don't know what you're saying, just trying to talk through your thought process, because your tutors or the interviewers will build on that and use that to guide you to the next step. But yeah.
Can anyone else hear?
I can't hear Helena.
Can't hear you, Helena.
I muted myself because I was typing. Thank you. Yes, I was just saying, brilliant tip there. And yeah, don't be afraid to ask questions of the interviewers as well, to get that conversation going. Brilliant. Cara, did you want to add something to all of that?
Yeah, I just wanted to continue off that. So like, they're not expecting you to sort of immediately, they're not expecting you to know the answer. They want to see you working through it, and they'll discuss it with you. And yeah, so like Anthony said, just saying what you're thinking, and they can help guide you through it as well, because ultimately they want you to get the right answer, but it's also about the process.
Absolutely. And it is worth mentioning that this year the interviews are going to be online again. There's more information about that on the university website, and that will keep being updated as the sort of technology and the format of it all gets confirmed. So it'll be slightly different like format, but the premise is going to be exactly the same. So all the advice that you've just heard will still apply to the online interviews. Brilliant. So another question here. How did you prepare for the PAT, so the Physics Aptitude Test? Any advice on preparing for that? Charlotte?
It's quite a boring answer, but I tried to know my A-level content pretty well, and they send out I don't want to say it's like a syllabus, but it's kind of like a maybe 10-page document of things you have to know, and that's kind of like the key into it. Like those are the topics that they will ask about, so those are the topics to revise more. Also, they put out quite a lot of past papers. I know Helena was saying that she's recording some like PAT answers that are going on the YouTube channel, so you can find solutions here and there, but maybe like the solutions aren't the most important thing. It's just kind of like looking at the questions and thinking, how would you approach this? There's not always just one right answer as well. Yeah, so I think just the past papers and kind of picking up on, like, they always ask something about like space, and they like you to be able to integrate things well. So topics like that you can revise in more detail.
Thank you for the little plug there for my YouTube series in collaboration with the physics department. Yeah, we're doing some little short videos going through some solutions to past PAT paper problems, and you can find them on the Department of Physics YouTube. New video every Tuesday. Brilliant. Anthony, do you want to say something as well?
Yeah, just hopping on from what Charlotte said there, I think exposure as early as possible. So something which I found quite useful was, so I guess I know it's a different stage now, but when I started year 12, something that our physics teacher would do, so he wasn't very familiar with the PAT at all, so, and the school which I went to weren't so familiar with the PAT, but once a week, every lunchtime, we just sort of pick a paper and just look at one question. And over the course of the year, that exposure definitely helped me along the way. And I feel like even if you haven't looked at a PAT paper now, it's not too late, but we'll definitely recommend just sort of like introducing yourself to that content right now and seeing as many different online videos as sort of Helena mentioned, the birthday series. And there's so many different people on YouTube who are talking about the PAT, or maybe introducing techniques and things like that. So I would highly recommend sort of increasing your exposure as early as possible and not waiting until September or October. So like really utilizing the summer to increase your awareness of the content, as Charlotte said, as well as just the techniques, or yeah, things like that.
Brilliant advice. Brad, do you want to add to that as well?
Yeah, I would say just like Charlotte said, there's kind of a mini syllabus that will come out for it, and I think it's it's roughly based on an A-level syllabus, but there's some things that maybe your school might be planning on teaching you in the Easter term after you've sat the PAT. So there are some bits of your physics course at school that you'll need to like be ahead on, and you'll need to kind of learn them before your school will have taught them to you. So just making sure that you've covered all of the topics that might be done in it. I would also say it's just so different to what you sit in a GCSE or A-level exam. Doing past papers is obviously helpful, but it's not going to be the same as GCSE and A-level exams, where questions will be asked in a very similar style year on year. I think just because you've done loads of past papers doesn't mean that you'll necessarily know the type of questions that are going to come up. There's much more thinking about them involved than there is probably in an A-level exam.
Absolutely. It's all about that problem solving stuff. Brilliant. Yeah. Echo all of the advice there. Past papers is the best way to practice, and make sure you check the syllabus and teach yourself anything that you might not have covered yet in class. Cara?
If you can find people to do PAT test preparation with, that I think that really helps to be able to discuss your answers as well.
Absolutely. Great. Thanks for adding that. Yeah, always talking your answers through with other people, and that extends through to when you're studying at university as well. It's really good to chat through the problems on your problem sheets before you go to your tutes. tutorials. Sorry, I use the abbreviations. But yes, definitely talking through problems with other people to help you prepare. Brilliant. So next question. So there's a couple of questions kind of asking about the split between sort of chemistry and physics on the course and what sort of physics topics are included in material science. So does anyone want to offer any thoughts on that? So the physics chemistry split and sort of what physics and chemistry topics there are in materials. Cara?
I think the so when I first started the course, I found it was a bit of a shock to the system for me, at least, because the way of thinking was quite different from sort of the chemistry that you're used to at A levels. I'd say that the A level chemistry that I learned was helpful, but it was mainly applicable in polymer courses and some sort of thermodynamic courses as well. In terms of the physics, I'd say it's more physics based than it is chemistry, but it's not sort of it's a very engineering physicsy sort of overlapping. Yeah,
that's probably a good way of describing it. Brad, do you want to add to that?
Yeah, my kind of take on it would be a bit that I think the course and the way the course is probably taught and the way that you need to tackle problem sheets and things like that is, I found it more similar to how I was taught physics at school, and that kind of, there's a lot of things about forces on objects and working out mathematically, like trying to work out what equation you need to use and working through that equation mathematically. However, I would say that actually the knowledge base that you need to do the course is probably more derived from chemistry. I had a look through a A-level chemistry syllabus the other day, and I went through it, and I think just about every single point on the A-level chemistry syllabus is used at some point in the materials course. Having the knowledge base from chemistry is pretty vital. But the way you work through things is more similar to physics. And as much as there is quite a lot of the physics that's used, there's probably quite a lot of the physics course that isn't used in materials. Things like a topic on space and things like that, like, just doesn't really matter in terms of the knowledge, but the way in which you'd solve the problems in an exam is more similar.
Great insight there as well. Thank you. Anthony, do you want to add to that as well?
Yeah, so I guess this is a quick plug to my tutors at St. Catherine's College, but one of the things that one of my tutors taught me early on in first year was that I guess from A-level, I was very used to seeing chemistry as its own A-level subject and physics as its own A-level subject, but that coming to university, specifically with material science, there's a lot of lateral thinking, and there's a lot of bringing together of physics concepts with chemistry together at the same time, even within one specific question. So rather than compartmentalizing them into these different boxes, as we're used to at A-level or IB or whatever the equivalent, something that I would definitely encourage from day one is seeing them as subjects that are very intertwined, and that the knowledge sort of feeds into one another, and that you can always draw from them both. And again, of course, even though chemistry is not a mandatory subject, just sort of seeing the physical chemistry knowledge that you're learning as things that's going to link into your physics knowledge that you're within the course. So I just sort of would definitely encourage stepping from A-levels or college into university to seeing these subjects as working together rather than isolated subjects.
Nice, really nice comment there. And yeah, like Anthony said, chemistry, A-level or equivalent, isn't an essential subject for applying to materials, but it is highly recommended. So if you don't study chemistry, that doesn't necessarily mean that you can't apply, and you won't be at a disadvantage purely because you're not studying chemistry, but it is very, very useful and very much recommended for the course. So we've had a lot of people asking about that. So just out of curiosity, did all of you study chemistry at A-levels? Yeah. What do you think, if you hadn't studied chemistry, how do you think starting on the course would have been in first year? Because obviously because it's not an essential subject, first year will cover all the chemistry that you need, but it'd be just interesting to hear who had the hand up first. Charlotte, we'll go with you.
I think that as long as you're kind of familiar with like moles calculations, they do kind of like pop up a bit randomly, but I think you cover that at GCSE. So like maybe if you're not doing chemistry, but you do want to do material science, you can revise that a little bit. We do some polymers courses. One of them is an option, so you can avoid that, but there are a few that you have to do. And you do get taught everything you need again, but it could be worth like brushing up on like what happens when you have carbons and hydrogens in a big chain together. But I don't think like factually, like you don't have to go and learn like all the organic synthesis stuff, like that kind of doesn't come up so much. Like everything is taught from like the ground up, really.
Exactly. Brilliant. Brad, do you want to add on to that as well?
Yeah, I think if you haven't studied chemistry, I mean, having studied chemistry, there was some repetition with things that you learn at school that are in the course. So I think if you've studied chemistry, your life's just a little bit easier than if you haven't studied chemistry, really.
Brilliant. And Cara, did you want to add to that as well?
I just I know people on the course who haven't studied chemistry, and they've been fine. Yeah, and say similarly with further maths, there's a further maths course that catches you up as well. So whatever you take for A-levels, you'll get there in the end.
Brilliant. Some good advice and comments on that. Excellent. So we've had a question here asking what tutorials are like. So does anyone want to tell us what your tutes have been like? So tutes is an abbreviation for tutorials that we use in Oxford. You might hear us say that a bit. Cara.
I'd say that they're a lot more informal than classes in A-levels, so that you get to know the professors at your college, and they're the ones teaching you, and sometimes they're the ones giving the lecture courses as well. And it's you do your problem sheets, and you go to the tutorial, and it's very much like a discussion, and the more questions you have, the more you get out of it, really.
Absolutely. Anthony?
Yeah, I really feel the tutorial system is such a great asset to the university here and the course, because I feel like, and I guess my main key that I learned very quickly is you sort of lose this sense of feeling like, oh, I can't look like I don't know anything, because you might be with a tutorial partner and he's saying or she's saying the same thing, or they're saying the same thing, that they're hoping that the other person, they don't want to look bad, but ultimately sort of letting go of that feeling of, oh my gosh, do I know what I'm saying? Do I not know what I'm saying? Do I understand the content? I think a tutorial is really there to break the lecture course down to you, and your tutors are really there to help. And as Cara said, the more questions you have, the better it is, because there's been times when I've sort of walked into a tutorial and maybe there was 6 questions to do, and I've only done 2 out of the 6, and I've just really tried on the rest. And I felt, oh my gosh, I'm going to look like so silly. But then my tutorial partner has done 2 out of 6 as well. And it's like, oh gosh, we're in the same boat. And sort of being honest enough to articulate that you've made an attempt, but you're just struggling with certain areas. I've always left the tutorial feeling like, wow, that makes so much more sense. That I'm so grateful to have had that broken down in that sort of 1 to 2 format. So yeah, they've been so helpful for me over the years.
Brilliant. Does anyone else have anything they want to say about tutorials? Or does that pretty much sums it up, really? Yeah, I think they should definitely be that sort of two-way dialogue, and learning to not be afraid to appear like you don't know something is definitely something that you have to get used to very quickly. But once you're comfortable with that, you find you get a lot more out of it. So that's definitely true. So there's been a few questions here asking about computing as a skill in materials. So is computing a necessary skill for the course, and sort of how much computing is there within the course? Charlotte, go ahead.
So no computing knowledge is required at all when you arrive. In the last, I think I was the first year that had, maybe the second year, that had a computing course in MATLAB. In the first year, it's like a couple of hours every other week, and you get like a project, but it's taught all from from knowing nothing. There are always some people that do know a lot about computing and then can take that further. So wherever you are, like on the computing spectrum, is like a good place to be. There are a couple of labs in second year where you will use MATLAB again, but not a huge amount. And then in the third year, you can either choose like a characterization project to do for 2 weeks that Carl was talking about earlier, or you can do 2 weeks of coding. And I think that's in Python, but I could be wrong. And then also in your fourth year, when you choose, you can do like any project. There's a massive long list of projects you can do then, and you can avoid computing at all costs if you want to, or you can do a whole year worth of computing if that's what suits you. There's a lot of choice, and you can come to it knowing a lot or nothing, and there'll be something for you.
Brilliant. Cara.
So yeah, like Charlotte said, you don't need any computing skills. I mean, if you know how to use Microsoft Excel, that's going to pretty much get you far. I mean, I've used MATLAB not that much. I mean, it's taught to you, but most of my course I've just been using Excel spreadsheets, and in some cases it's far better than MATLAB, which is a coding software which is better for if you want to automate some sort of data analysis. The modeling project that Charlotte mentioned in third year uses a specific software which I think the coding, I'm not entirely sure, but I think the coding language was written by one of the members at Oxford University. I'm not sure, but it's used specifically for like modeling materials and atoms, and hence finding out material properties from that. It uses principles from electronic orbitals and stuff like that, which you'll learn if you choose to take those modules. Yes.
Brilliant. So that leads nicely on to the next question. So for those of you who have done your research projects, what were your projects on? What did they involve? Cara, again, go ahead.
I was working on carbon-carbon composites in James Marrow's research group, Professor James Marrow, and I was looking at a particular small specimen test geometry about this big in situ measurements. So I was putting them in X-ray scanning tomography machines and taking doing compression tests and taking measurements and seeing how the material fails and cracks propagate, and looking for stable crack propagation. And the ultimate goal was to find the fracture toughness, but the material was it was quite brittle, and it had lots of pre-existing cracks in it, so it just sort of buckled, all the fibers buckled, and so I was just looking at how it broke, and using some fancy software which I was taught when I started my research project. And yeah, so again, if going back to the coding, like if you need to learn another software, there's plenty of people who will be able to help you if you have issues.
Brilliant. That sounds really interesting. Anthony, how about you?
Yeah, so I guess to start, something I was going to say earlier, but I forgot. But going back to, I think when the question was asked about what's the best bit of the course, so for me that answers in two halves, and one half is definitely the fourth year project. So it's echoing what I believe Brad was saying earlier, because for me, up until the end of the third year, I thought, the course is cool and everything, but by the end of the fourth year, I got so engrossed in my project that I ended up applying for a PhD to stay within the department. So it really swayed me from one way to the other, and I just really enjoyed it. So essentially, my project was based on using an atom probe, which when I used to describe this, I used to be able to say that, there's only one of these in the UK, and Oxford is the only place in the UK which has an atom probe. But I think Imperial might have got the funding to get their own. But anyways, for now, I'm still going to say that we're the only one in the country which has an atom probe. And essentially, that allows you to look at the atomic arrangement of elements in specific and any alloy, really. So I had 2 iron alloys, specifically high temperature superalloys, and just trying to better understand their properties, where the iron was moving, where all of the elements within the alloys, where they were located, if there was specifically in certain regions, if they had a preference for certain areas within the alloy, and using this to therefore determine its suitability as an alloy in high temperature applications. So it was really quite cool. So just using this piece of equipment, which costs a lot of money, and feeling like there's no one else in the country who has access to this. And in order to come with a verdict and to say whether or not you believe this alloy is suitable or not suitable for its application, I felt it was quite cool to be able to come at the end and be like, you know what, with all my research, I think this alloy is not good enough. And it was like, wow, I've got all this research to support that too. But yeah, I guess that's a bit of a summary of what I was doing.
Oh, that sounds really cool. Nice one. Brad, how about you? What were you doing?
Yeah, I'll just go on what Anthony was saying a second. The atom probes, yeah, Imperial do have one now, which means that we're not the only one in the UK, but we do have 3. So I reckon that keeps us on top. They were also designed, and the first one was built in Oxford. So we've still got our niche, but they're really cool bits of kit. You can image individual atoms in 3D space and build up these ridiculous resolutions of materials, which are really, really impressive. My project is looking at nuclear fusion. I'm trying to develop new alloys that can be used at the high temperatures and the corrosive environments that are present in nuclear fusion reactors to try and basically, nuclear fusion kind of works. We can get a plasma to work and produce energy, but we currently have no way of converting the energy that's produced into electricity that can be useful for the grid. So there's quite a few different ideas around how it might be done, and I'm looking at trying to design new metals so that one of them can be done. So that involves me getting pure metals, melting them, alloying them. These are extremely high melting temperature metals as well, so you need quite advanced techniques just to be able to make them into alloys, and then designing experiments and creating experiments so that we can test how these metals would behave in a fusion environment. Yeah, there's a lot of, especially near the start of my PhD, and there's a lot of hands-on work to try and make these experiments work before I can start collecting data from them.
Nice. And am I right in thinking that you worked on that as your project in your 4th year, and then you just continued it with your PhD?
Yeah. So my fourth year project was designing alloys, making them, and then doing some microstructural characterization on them. So that is, we have an excellent suite of microscopes in the department. So scanning electron microscopes and all of the different bits that come with that was what I was using. Just to image them and understand their microstructure, which is something that a lot of the course is based on. So that's probably a word that doesn't mean a lot to you before you start the course, but about a week in, you'll have heard the word microstructure so many times. So that was a lot of my 4th year project, and this year I'm taking it a little bit differently and trying to do some experimental tests to get some data about the alloys and how they behave, and also carry on doing some of the imaging as well.
Brilliant. Sounds very exciting. Cara, do you want to add on to that?
It's maybe a slightly off topic, but I just wanted to mention that the range of equipment that the materials department has access to when you're doing research project is really quite amazing. And for example, in my research project, it was in collaboration with the Australian Nuclear Society. They sent over samples specifically because of the equipment technology that the materials department has with being able to do 3D scans as things break. That was their interest, and of course with the atom probe, we've got that, and loads of different types of microscopes and some very specialized equipment. And there's also there's like a branch in just outside of Oxford in the Bowbrook Science Park, which has some specialized equipment in polymers and solar panels and stuff. I know that that there's loads of different characterization techniques being developed as well at Oxford. I was lucky enough to work on the calcium test in the summer research project, which was developed in Professor Hazel Assinger's research group, which was looking at the permeability of water through polymer thin films. So there's a wide range of projects and research that you can do in your fourth year.
Brilliant. Thank you for that. Yeah, absolutely. There's such a range of different subjects within material science and research going on in the department, and you get the chance to join them in your fourth year. Cara, again, yeah. And
also you often collaborate with different departments sometimes. I think with the coding projects that you can do in fourth year, you're using some of the supercomputers that are used across many departments, and the equipment is used. Some of the equipment that you might be using can be used by research groups from other departments as well. Yeah.
Brilliant. Yeah, thanks for adding that. Awesome. So we've heard about the research. So we've got another question asking, what jobs are you looking to do with a material science degree? So what are your plans after you finish? Who wants to start? Charlotte, go for it.
So a lot of my friends are looking into becoming like engineers, whether that's in like sustainability or with cars or with like optical fibers, all that kind of stuff. Some people are wanting to go into like finance, like go into the city. I think I want to go back to school and be a teacher, probably a maths teacher, so a little bit more boring. But yeah, there's so many different things that people get up to after doing material science.
Teaching is absolutely not boring. I will definitely vouch for that. Brilliant. Cara, how about you?
I was thinking of probably continuing with research, but for not in terms of a PhD, but more for like companies. But also like there's a lot of, we get taught a lot of manufacturing methods, and I might at some point go into blacksmithing or something like that. So we'll see.
Well, that's really cool. How about you then, Brad?
Yeah, so I think in terms of, like Charlotte said, there's quite a lot of people who go and do some mad things like go to the city, or some other things that are not very materials related. One of my friends from undergrad has gone and started working on movie sets, designing special effects and things like that, which is quite cool. But I'm not sure how much this degree is helping him, but it just shows you can do quite a lot of things. In terms of staying in materials and things like that, materials are used, well, knowledge of materials is used across industries, so many industries, and everyone needs a knowledge of it. A lot of places won't have in-house materials experts. Some places will, some of the big, very big companies and things like that will have in-house materials experts. Especially things like some of the big car companies or big consumer companies, people like P&G or somebody like that. But then there's quite, the more common would be to go to work for some kind of engineering consultancy who would have materials experts and then work across a range of projects at different companies. So, for example, one of the jobs that I was looking at before I decided to take my PhD was a nuclear consultancy. So rather a lot of, not all nuclear reactors will have material specialists on site at some of the nuclear reactors that are around the UK. So they'll use, if they need to examine materials that have come out of their reactors, they'll be sent to a consultancy who will do that across the UK. So that's probably a more common way to be able to stay in materials rather than going to one specific company.
Nice. Anthony, how about you then?
Yeah, so I sort of mentioned before, so 12 months ago, I was sort of looking at maybe gateways out of materials and sort of like maybe the consulting route, but as again, plugged to the fourth year project, that literally swayed me the other direction. And hence why I sort of having the offer to stay in the in Oxford and do a PhD within the same research group that I'm in. But I guess one of the things that I've been looking at is even within the PhD and maybe time afterwards is to transition into maybe the startup space. A specific area that I'm interested in is the crossover between maybe nanomaterials and medicine. So that's something which I'm sort of keen to explore and in the free time outside of the PhD and maybe just see where that takes me. So and especially speaking to a few people, it seems like of course a PhD having the demanding hours and things like that, but there is that free time to maybe explore things, adventures outside of it. And I definitely feel like I would want to stay and maybe explore, yeah, that crossover between medicine and nanomaterials.
That sounds really cool. I imagine there's a lot of research going into that at the moment. Brilliant. Cara, how about you?
I just had a thought that I know of one member of the materials department. He set up his own chocolate company with his knowledge of material science, and I also know that one material science graduate went on to make her own tea company with her material science knowledge. So there's quite a range that you can do.
Absolutely, so many different things you can do. That's really cool that there's so many people doing so many different things, which is really exciting. So kind of following on from that, we've had a question asking, did you imagine yourself ending up doing these projects or being interested in these things 4 years back when you first started your degree? So does anyone want to comment on that? Did you know you were going to be interested in what you ended up being interested in, or has it changed? Brad?
Yeah, not at all. I knew nothing about nuclear technology when I started my degree. I fully learned about it here. Was quite lucky to be given the project I was given, and really enjoyed it, and learning off the people here. So yeah, definitely. Yeah, had no idea about what I'm doing now 4 or 5 years ago.
Awesome. Cara, how about you?
Like I mentioned earlier, I was initially interested in bioengineering, and I was when I wrote my personal application, I was very interested in sort of gels and aerogels and stuff like that. But 4 years later, here I am, and I really enjoy things like metallography and sort of composite materials as well. So completely opposite in terms of research areas. Yeah.
I feel like that's quite common because there's so much covered in the course that you probably wouldn't have even touched upon in school or even be aware of, that your thoughts of what you're interested in right at the start, like what you write about in your personal statement, by the time you're doing your project in 4th year will probably be completely different. And I think that's what makes the course quite exciting. I don't know about you guys, but yeah. Brilliant. So had several questions here asking about books. If you have any book recommendations for interview prep or for personal statements. Now, I know we have a list on our website, but are there any specifically that you guys think are really good? Brad?
Yeah, there's one that is, I would bet all 4 of us wrote about on our personal statement, and I reckon about 95% of people who apply for materials write about on their personal statement, which is Stuff Matters by Mark Miodownik, who is he did his undergrad and his PhD, I think, at Oxford. He's a science communicator now, and it's a very good book, very accessible, and some really good science in it. My personal take would be a little bit different. I would personally, I don't read a lot. I'm not a big fan of reading. And there is a reading list on the website, and there are some very good books on it. I would personally try and find something a bit different. Like I said, the tutors would have seen analysis in personal statements of Stuff Matters so many times. Something a bit different could be a bit fun. There are loads of, especially in lockdown, loads of podcasts and stuff have started coming up, YouTube videos, online lectures. trying to find something a bit different, something that interests you specifically. Try and relate it to something else that might be a hobby, things like that. Yeah, trying to make it personal, try and find something a bit different is always a good way to go.
Yeah, excellent. Does anyone else have any good recommendations for, again, not just books, but other things as well? Anthony?
Yeah, I completely agree with Brad. So similarly, I resisted the temptation to talk about Stuff Matters in my personal statement. I think the book that I did mention, I think is like called J.E. Gordon, Why You Don't, I can't remember, something along the lines of
Why You Don't Fall Through the Earth or something, isn't it?
Yeah, something like that. But again, like Brad, I wasn't really interested in reading books as much. For me personally, I remember I think the first line of my personal statement was based on a YouTube video that I'd watched on the material Vantablack, which I just, because for me, my main form of interest sort of stemmed from watching YouTube videos, and I think it was on a YouTube channel called SciShow, and yeah, that was just my gateway in. Rather than books, I was talking about YouTube videos I'd watch on novel materials, and that was something that I found particularly interesting. And though I didn't find a materials channel that was a YouTube channel that was dedicated to solely talking about material science, there were a bunch of physics or sort of engineering related channels that I found, which occasionally might venture into the material science side of things. And personally, I would much rather watch a 20-minute video than read a book. So that was sort of my way in.
Brilliant. Does anyone else have anything to add on that sort of advice for personal statements, books, videos? Did anyone do any interesting work experience or anything like that before they started? Or no? See, just goes to show you don't have to have a ton of in-person work experience. Just simply finding something interesting to watch on YouTube that sparks your interest and that you can talk about is brilliant. Cara?
I did have some work experience doing. I was part of the engineering education scheme, and I worked as part of the student team with Mott MacDonald, looking at tidal lagoons and water, turbines and stuff. And I was asked about that in my interview. But in terms of books, I think I pretty much just looked on the Oxford website and found ones that I thought were interesting. But I think if I could go back, I would probably think about what I'm personally interested in and maybe find some books online that, if I wanted to read books about it, then find some books. For example, if I were interested in corrosion, I'm aware of a book called Rust. I think it's literally called Rust, and I haven't read it, but it seems like a good read. I know it's not on the Oxford Materials reading list at all. So just find things you're interested in, really. And if you can find work experience that is just something that you can chat about comfortably, but the same thing goes for any reading that you do as well.
Yeah, brilliant. And a really good point there, Cara, as well. Find something that you are specifically interested in. Don't just read a book for the sake of reading a book and being able to put it on your personal statement. Definitely find something that you're interested in. And like we already said, videos, podcasts, articles, books, anything is brilliant. Okay, so it is 2:00. So I think it is time to stop. Does anyone have any last sort of closing remarks they want to say to anybody watching this? Or shall we wrap up here? Charlotte, go for it.
It gets said quite a lot at open days, but if people are nervous about applying, the only way you have a 0 chance of getting in is if you don't apply. So just apply. You've got 5 options. Might as well put it down.
Brilliant. I think unless anyone else wants to say anything, I think that's an excellent note to end on. So thank you so much for being here to answer all these questions. Thank you to the audience watching, anyone who's watching this live or watching it on playback after it's been saved. Thank you so much for your questions, and hope you enjoy the rest of the open days. So bye.
Thank you. Bye.